my dear students, welcome to Teacher at Home. Today class we are going to learn the 11th chapter, Chemical Effects of Electric Current. Your elders might have cautioned you against touching an electric appliances with wet hands. നനഞ്ഞ കയ്യിൽ കറണ്ടിൽ സ്വിച്ചിൽ തൊടരുതെന്ന് പറയാറുണ്ട്. But do you know why it is dangerous to touch an electrical appliances with wet hands? We have learned earlier that the materials which allow the electric current to pass through them are good conductors of electricity. അപ്പോൾ ഏത് വഴിയാണോ ഈ കറണ്ട് പാസ് ചെയ്യണത് അവർ എന്താണ് പെട്ടെന്ന് തന്നെ പാസ് ചെയ്യാനുള്ള കഴിവുള്ളതാണ്. On the other hand, materials which do not allow electric current to pass through them as poor conductors പറഞ്ഞ ഇലക്ട്രിസിറ്റി അതിലൂടെ പാസ് ചെയ്യില്ല. Class 6, we made a tester to test whether a particular material allows the electric current to pass through it or not. Can recall how the tester helped us in designing that. We found that metals such as copper and aluminum conduct electricity. അപ്പോൾ കോപ്പറും അലുമിനിയം എന്ത് ചെയ്യും ഇലക്ട്രിസിറ്റി പാസ് ചെയ്യും. Whereas materials such as rubber, plastic and wood do not conduct electricity. However, so far we had used our tester to test materials which were in solid state. But what about liquids? Do liquids also conduct electricity? Let us find out. Paheli and Bojo want to remind you too that one should not experiment with electric supply from the mains or a generator or an inverter. ഇലക്ട്രിസിറ്റിയിൽ നമ്മൾ ടച്ച് ചെയ്യുമ്പോൾ നല്ലോണം സൂക്ഷിച്ചിട്ട് വേണം ആ എക്യുപ്മെൻറ്റ്സ് ആയിട്ട് വർക്ക് ചെയ്യുമ്പോൾ. യൂസ് ഓൺലി ഇലക്ട്രിക് സെൽസ് ഫോർ ഓൾ ആക്ടിവിറ്റീസ്. ഡു ലിക്വിഡ്സ് കണ്ടക്ട് ഇലക്ട്രിസിറ്റി? To test whether a liquid allows electric current to pass through it or not, we can use the same tester ഉപയോഗിച്ചിട്ട് തന്നെ നമുക്ക് ചെയ്യാൻ പറ്റും. However, replace the cell by a battery. Also, before using the tester, we should check whether it is working. അത് വർക്ക് ചെയ്യുന്നുണ്ടോ ഇല്ലയോ എന്നുള്ളത് ആദ്യം ടെസ്റ്റ് ചെയ്യണം. Activity 11.1. Join the free ends of the tester together for a moment. Just complete the circuit of the tester and the bulb should glow. However, if the bulb does not glow, it means that the tester is not working. Can you think of the possible reasons? Is it possible that the connections are loose or the bulb is fused or your cells are used up? Check that all the connections are tight. If they are, then replace the bulb with another bulb. Now test if the tester is working or not. If it is still not working, replace the cells with fresh cells. Now that our tester is working, let us use it to test the various liquids. Collect a few small plastic or rubber caps or discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in 1 cap. Bring your tester over this cap. Let the ends of the tester dip into lemon juice or vinegar. Take care that the ends are not more than 1 centimeter apart and at the same do not touch each other. Does the bulb of the tester glow? Does lemon juice or vinegar conduct electricity? How would you classify lemon juice or vinegar? Lemon juice ഉം വിനേഗർ ആണ് നമ്മളൊരു ഇതിൽ എടുത്തിരിക്കുന്നത് അല്ലേ? അതെങ്ങനെയാണ് പൂർ കണ്ടക്ടർ ആണോ ഗുഡ് കണ്ടക്ടർ ആണോ എന്ന് എങ്ങനെയാണ് അറിയുക? Lemon juice. When the liquid between the two ends of the tester allow the electric current to pass, the circuit of the tester becomes complete. The circuit of the tester becomes complete. The current flows in the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester it is not complete and the bulb does not glow. In some situations, even though the liquid is conducting, the bulb may not glow. It may have happened in activity 11.2. Okay, do you remember why the bulb glows when the electric current passes through it? Due to the heating effect of current, the filament of the bulb gets heated to a higher temperature and it starts glowing. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. And why is the current in the circuit weak? Well, though a material may conduct electricity, it may not conduct it as easily as a metal. As a result, The circuit of the tester may be complete, and yet the current through it may be too weak to make the bulb glow. Can we make another tester which can detect a weak current? We can use another effect of an electric current to make another kind of tester. Do you recall that electric current produces a magnetic effect? What happens to a compass needle kept nearby when current flows in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Can we make a tester using the magnetic effects of current? Let us find out the activity. We may use an LED in place of the electric bulb in the tester. LED glows even when a weak electric current flows through it. There are two wires called leads attached to the lead. One lead is slightly longer than the other. Remember that while connecting to a circuit, the longer lead is always connected to the positive terminal of the battery and the shorter one is connected to the negative terminal of the battery. Take the tray from inside a discarded matchbox. Wrap an electric wire in a few times around the tray. Place a small compass needle inside it. Now connect one end of the wire to the terminal of the battery. Leave the other end free. Take another piece of wire, connect it to the other terminal of the battery. Join the free ends of two wires momentarily. The compass needle should show deflection. Your tester with two ends of the wire is ready. Now repeat activity using this tester. You will find a deflection in the compass needle the moment you dip the free ends of the tester in lemon juice. Take out the ends of the tester from the lemon juice, dip them in water and then wipe them dry. Repeat the activity with other liquids such as tap water, vegetable oil, milk, honey. Remember to wash and wipe dry the ends of tester after testing each liquid. In each case, observe whether the magnetic needle shows deflection or not. We find that some liquids are good conductors of electricity and some are poor conductors. When the free ends of the tester do not touch each other, there is an air gap between them. Paheli knows that air is a poor conductor of electricity, but she has also read that during lightning, an electric current passes through air. She wonders if air is indeed a poor conductor under all conditions. This makes Bojo ask whether other materials classified as poor conductors also allow electricity to pass under certain conditions. Actually, under certain conditions, most materials can conduct. That is why it is preferable to classify materials as good conductors and poor conductors, instead of classifying as conductors and insulators. We have tested the conduction of electricity through tap water. Let us now test the conduction of electricity through distilled water. Take about 2 teaspoons of distilled water in a clean and dry plastic or rubber cap of a bottle. Use the tester to test whether distilled water conducts electricity or not. What do you find? Does distilled water conduct electricity? Now dissolve a pinch of common salt in distilled water. Again test what do you conclude this time. When salt is dissolved in distilled water, we obtain salt solution. This is a conductor of electricity. The water that we get from sources such as taps, hand pumps, wells and ponds, it is not pure. It may contain several salts dissolved in it. Small amounts of mineral salts are naturally present in it. This water is thus a good conductor of electricity. On the other hand, distilled water it is free of salts and is a poor conductor. Small amount of mineral salt present naturally in water are beneficial for human health. However, these salts make water a good conductor. So we should never handle electrical appliances with wet hands or while standing on a wet floor. We have found that common salt, when dissolved in distilled water, make it as a good conductor. What are the other substances which, when dissolved in distilled water, make it conducting? Let us find out. Take 3 clean plastic or rubber caps of bottles. Pour about 2 teaspoonfuls of distilled water in each of them. Add a few drops of lemon juice or dilute hydrochloric acid to distilled water in one cap. Now in the second cap containing distilled water, add a few drops of base such as caustic soda or potassium iodide. Add a little sugar to the distilled water in the third cap and dissolve it. Test which solution conduct electricity and which do not. What results do you obtain? Most liquids that conduct electricity are solutions of acid, bases and salt. When an electric current flows through a conducting solution, does it produce an effect on the solution? Chemical effect of electric current. In class 7, we have learned some effects of electric current. Can you list these effects? What effect does the current produce when it flows through a conducting solution? Let us find out. Take out carbon rods carefully from two discarded cells. Clean their metal caps with a sandpaper. Wrap copper wires around the metal caps of the carbon rods and join them to a battery. We call these two rods as electrodes. Carbon rod, metal cap, carbon rod, water. Carbon rod, you may have two iron nails about 6 cm long. Pour a cupful of water in a glass plastic bowl. Add a teaspoonful of salt and a few drops of lemon juice to water to make it more conducting. Now immerse the electrodes in this solution. Make sure that the metal caps of the carbon rods are outside the water. Wait for 3 to 4 minutes. Observe the electrodes carefully. Do you notice any gas bubbles near the electrodes? Can we call the change taking place in the solution of a chemical change? Recall the definition of a chemical chain that you learned in class 7. In 18, a British chemist, William Nicholson, had shown that if electrodes were immersed in water and a current was passed, bubbles of oxygen and hydrogen were produced. Oxygen bubbles formed on the electrode conducted to the positive terminal of the battery, and hydrogen bubbles formed on the other electrode. The passage of an electric current through a conducting solution causes the chemical reactions. As a result, bubbles of a gas may be formed on the electrodes. Deposits of metal may be seen on electrodes. Changes of colors of solutions may occur. Reaction would depend on what solution and electrodes are used. These are some of the chemical effects of the electric current. Bojo decided to test whether some fruits and vegetables also conduct electricity or not. He cut a potato into two halves and inserted the copper wire of a tester into it. Just then his mother called him, and he forgot to take out the wires of the tester inserted into the potato. When he came back after half an hour, he noticed that there was a greenish blue spot on the potato around one wire, whereas there was no such spot around the other wire. He was surprised with this observation and, along with Paheli, repeated the activity many times. He found that it was always the wire connected to the positive terminal which had a greenish blue spot around it. They felt that the discovery was very useful because it could be used for identifying the positive terminal of the cell or a battery concealed in a box. They decided to report their finding to a children's magazine. Remember that Bojo set out to test whether potato conducted electricity or not. What he found was the current produced a chemical effect in the potato. To him, this was very exciting. In fact, this is how science sometimes works. You are looking for something and you discover something else. Many important discoveries have been made in this manner. Electroplating. You know that a brand new bicycle has shiny handlebar and wheel rims. However, if these are accidentally scratched, the shiny coating comes off, revealing a not so shiny surface beneath. You might have also seen women using ornaments which appear to be made up of gold. However, with repeated use, the gold covering wears off, revealing silver or some other metal beneath. In both these cases, a metal has a coating of another metal. Do you wonder how a layer of one metal can be deposited on top of other? Well, let us try doing it ourselves. We'll need copper sulfate and two copper plates of size around 10 cm 4 cm. Take 250 ml of distilled water in a clean and dry beaker. Dissolve 2 teaspoonfuls of copper sulfate in it. Add a few drops of dilute sulfuric acid to copper sulfate solution to make it more conducting. Clean copper plates with sandpaper. Now rinse them with water and dry them. Connect the copper plates to the terminals of a battery and immerse them in a copper sulfate solution. Copper plate, copper sulfate solution. Allow the current to pass for about 15 minutes. Now remove the electrode from the solution and look at them carefully. Do you find any difference in any of them? Do you find a coating over it? What color is the coating? Note down the terminal of the battery with which this electrode is connected. After doing the electroplating activity, Paheli interchanged the electrodes and repeated the activity. What do you think she would observe this time? When the electric current is passed through the copper sulfate solution, copper sulfate dissociates into copper and sulfate. The free copper gets drawn into electrode connected to the negative terminal of the battery and get deposited on it. But what about the loss of copper from the solution? From the other electrode, a copper plate, an equal amount of copper get dissolved in the solution. Thus, the loss of copper from the solution is restored and the process continues. This means that copper get transferred from one electrode to another. The process of depositing a layer of any desired material on another material by means of electricity is called electroplating. It is one of the most common appliances of chemical effects of electric current. Electroplating is a very useful process. It is widely used in the industry for coating metal objects with a thin layer of different metal. The layer of metal deposited has some desired property which the metal of the object lacks. For example, chromium plating is done on many objects such as car parts, bath taps, kitchen gas burners, bicycle handlebars, wheel rims, and many others. Chromium has a shiny appearance. It does not corrode. It resists scratches. However, chromium is expensive and it may not be economical to make the whole object out of chromium. So the object is made from a cheaper metal and only a coating of chromium over it is deposited. Jewelry makers electroplate silver and gold on less expensive metals. These ornaments have the appearance of silver and gold but are much less expensive. Tin cans used for storing food are made by electroplating tin into iron. Tin is less reactive than iron. Thus, food does not come into contact with iron and is protected from getting spoiled. Iron is used in bridges and automobiles to provide strength. However, iron tends to corrode and rust. So, a coating of zinc is deposited on iron to protect it from corrosion and rusting of formation of rust. In the electroplating factories, the disposal of the used conducting solution is a major concern. It is a polluting waste and there are specific disposal guidelines to protect the environment. Keywords: electrode, electroplating, good conductor, lead, poor conductor. Some liquids are good conductor of electricity, some are poor conductors. Some liquids that conduct electricity are solutions of acids, bases, and salts. The passage of electric current through a conducting liquid causes chemical reactions. The resulting effects are called chemical effects of currents. Process of depositing layer of any desired metal on another material by means of electricity is called electroplating. So that's all about this chapter. If you are interested, please do like, share, and subscribe my channel. Okay, thank you.